Okay, so welcome to TADHack, the Netherlands. We've dubbed our project SIG11, and it's a WebRTC peer-to-peer mashup. My name is Florian Overkamp. Next to me is Jeroen van Veen. Actually, our hack team is Jeroen and Wouter, who could not be here this afternoon. I've been here for moral support together with my colleagues Jarno and Nick. And hopefully we can tell you a little bit about our experiences these last 48 hours or so. But first I would like to talk to you a little bit about the state of the web. Today there is a lot of content. The bulk of all web content is hosted in the big tech companies, Google, Amazon, Apple and Facebook. And that's a problem because that opens us up for a lot of opportunities by companies and governments to interfere and to impact our society. This is one of the examples how the Russian government has been trying to impact US elections using Facebook. This is called political nudging. Another example is this in Turkey, where social media platform Twitter has been blocked using a DNS block, where a lot of the citizens have been going to public Google name servers to actually go to the platform. This is hindering our society, our freedom. And peer-to-peer can help solve that problem by removing or decentralizing server infrastructure. If we decentralize or remove infrastructure, there is less means to influence or hinder the communication. So that improves our privacy and our freedom. But decentralization technology, as it is today, is really complex. Even developers are still figuring out how the technology should work, let alone the tech being usable for normal end users without any technical skills. So what you would want to experience is a very simple application. I need to sign in and I can actually use the decentralized platform as a node, as a person with other people to talk to. Normal people won't use the technology if it is not as simple as something like this, because all of the other technologies that we use today are this simple. But creating an interface to do this should be simple and easy to use, but it is really hard. Which brings us to communication. Obviously we're at TADHack, so we have to talk about telecom applications. And one of the technologies to use is WebRTC. And WebRTC today, is already a little bit peer-to-peer, as we see the media streaming directly, but not entirely, because the signaling is still centralized. And this could still lead to problems, especially if you're not in friendly company.
Yeah. So, what we try to do is think about what you could do about the signaling part, because that's the only part that's problematic. Like companies and governments can just collect a lot of metadata from that point. The peer-to-peer connections between these two users are quite secure, and as soon the connection is established between these two users, then all is fine. But to get there, you need some way to establish a connection, and a signaling service is necessary to make it easy for the user to connect to another user by exchange of signaling information. But what if we just decentralize the signaling part as well? Each of these two users can generate a key pair in their browsers, and their public key is their identity on this network. And if Alice wants to connect to Bob, they can just exchange messages by encrypting the signaling information with each other's public key, which makes the discovery part encrypted as well. And as soon they got connected directly, then we don't have to bother anymore with the encryption because WebRTC encryption is used from then on. So how far did we get? Well, we don't have a real demo. We used an existing open source softphone client and changed it to connect to one of the nodes here, and made a somewhat of a stub implementation. So it basically looks like this: two clients, Bob and Alice. They want to call to each other. This is the node in between. This is the public key of Alice. Bob fills in the public key. It's not really user-friendly yet, but we come to that later on how to improve this situation. We had a slider to change from a SIP protocol to a decentralized signaling mechanism. Then a call is made over the signaling is done over the node to the other side, and an incoming call is registered. That's basically how far we got. Yeah.
Okay. So a lot of work still to be done. We had a lot of debate about how to do the onboarding process. Trusted identity at the onboarding stage needs to prevent people from impersonating others. And we did not want to do App Store installment, so we wanted to use a progressive web application for this. And we need some form of identity management in there. Obviously then the decentralized storage becomes the next component to look at. We've watched the status project a little bit on this. They do also talk to IPFS. That looks promising. An alternative might be the DAT project, but we've been really looking hard for native JavaScript implementations, because if that's lacking, then it's going to be really hard to get a progressive web app to do this. So we learned a lot. We didn't get where we wanted to be in this thing. It was definitely too big to swallow a project, but it was a great thought experiment, at least to debate how to keep the user experience friendly enough while still maintaining the security and the trust level. But being too paranoid makes this really, really complex. And we've been spending time learning a lot more about decentralization. We've both been looking into it a little bit, but definitely a deeper level to get to. Yeah. And that's pretty much it. So thanks. I think so. Yeah.